Welcome to our mathematics class. We are going to handle chapter 4, that is linear relationships. And in the first subtopic, we shall handle introducing linear relationships. So what is a linear relation? A linear relation is a set of ordered pairs x, y that when grabbed give a straight line. Let us consider the following illustrations. There are three rules here that we want to confirm whether they are linear or nonlinear relations. To confirm the first rule, whether it's a linear relation, we shall require to complete a table of values. To complete this table, we consider the first value of x, which is 1. So when x is 1, we can be able to find the value of y. That is, we substitute where there is x in our rule with 1. In this case, y1 will be equivalent to 2 divided by 1 plus 1. 2 divided by 1 is equivalent to 2. When we take 2 plus 1, the result is 3. Therefore, the first value in the table when x is 1, the y value is 3. Next, we consider a case where the x value is 2. What will be the y value? When the x value is 2, we substitute in our rule where there is x with the value 2. In this case, y1 will be 2 divided by 2 plus 1. The result will be 1 plus 1, which gives us 2. That means when the x value is 2, the y value is also 2. Now, in the last value, we are having 3 when x is 3. So class, we need to find out what will be the corresponding y value by substituting the same value x is 3 in our first rule. Now, when the x value is 3, the y value is 2 divided by 3 plus 1. And the result will be 1 whole number 2 over 3, which can as well be written as a decimal, corrected to 2 decimal places. So if we express it as a decimal, the value of y becomes 1.67. For the purpose of completing our table, we can just leave it as an improper fraction, that is 1 whole number 2 over 3. That is the first case, completing the table for the first case. Let us now consider the second case or the second rule and confirm the table values. In our second rule, y2 is equivalent to x squared minus 1 is the rule we are having. So we need to complete a table for using the same rule. So in that table, we have chosen the x values randomly. That is, we let the value of x to be 1, the second value of x to be 2, and the third value of x to be 3. However, you can choose any value of x. We need to confirm what is the value of y2 when the value of x is 1 by substituting x is equal to 1 in our rule. When we substitute the value of x is equal to 1 in our rule, we discover that 1 squared minus 1 gives you 1 minus 1, which is equivalent to 0. That means when the value of x is 1, the y value is 0. We now complete the table. Where there is x is 1, we put there y is 0. Now, we extend the same knowledge by taking the value of x to be 2. What will be the value of y? When the value of x is 2, we discover that the y value will be 2 squared minus 1. And 2 squared is 4, minus 1, which gives the result as 3. So in this case, when the value of x is 2, the corresponding y value is 3. Finally, we substitute in our relation the value of x when it is 3. We realize that when the value of x is 3, when you take 3 squared minus 1 is equal to 3 squared gives you 9, minus 1, and the result is 8. That means when the x value is 3, the corresponding y value is 8. That is what we fill in our table. Lastly, we consider our final relation, which is y3 is equivalent to 3x minus 4. We construct the table of values as follows. We substitute the first value of x as 1 in our relation. When we substitute the value of x as 1, 3 multiplied by 1, the result is 3. Minus 4, the final result is minus 1. It therefore means that when the value of x is 1, the corresponding y value is negative 1. Next, we confirm the value of y when the value of x is 2 by substituting in our relation. Having substituted in our relation, when the value of x is 2, the value of y is 3 multiplied by 2 minus 4. 3 multiplied by 2, the result is 6. Minus 4, we find that our result is 2. Therefore, it means when the value of x is 2, the corresponding y value is 2. Finally, we shall consider the last value of x when x is 3. What is the corresponding y value? From this illustration, we find that when the x value is 3, the y value is obtained by taking 3 and substituting the value of x as 3 minus 4. That means 3 multiplied by 3 gives us 9. Minus 4, we find that the result is 5. And therefore, when the value of x is 3, the corresponding y value is 5. We complete the table by replacing y with 5. Now we are through with the first part of completing the table. We are supposed to know how to identify the points from the table. In table 1, when we refer to table 1, when the value of x is 1, the y value is 3. So the coordinate is expressed as 1, 3. Similarly, in the second case, when the x value is 2, the y value is 2. So the coordinate will be expressed as 2, 2. And lastly, when the x value is 3, the corresponding y value is 1 whole number 2 over 3. So the coordinate will be 3, 1, 2 over 3. We can do the same for the table 2 and table 3 as follows. For table 2, the coordinates are 1, 0, and the second coordinate is 2, 3, and the final coordinate is 3, 8. We can repeat the same to table 3 as follows. In table 3, the coordinates are 1, -2, 2, 2, and finally 3, 5. That is how we complete the table. And now from our table values, we can be able to draw a graph so that we can identify whether the graphs, all the table values, are giving linear relations or nonlinear relations. So let us now move on and look at how we can draw a graph. Now we have our grid here where we shall be able to draw our graphs. We start by the first graph, that is graph for table 1, and plot these coordinates correctly. So the graph must have the axis. We need to have the vertical axis, which is called the y-axis. Then we have the horizontal axis, which is referred to as the x-axis. Now, when the two axes are joined, they intersect and divide the grid into 4 quadrants. We have a quadrant here on the right. We call it the first quadrant on the right side of the y-axis. We have a quadrant on the positive side of the y-axis, but the negative side of the x-axis is called the second quadrant. And we have a quadrant which represents the negative x values and the negative y values. It's called the third quadrant. And lastly, the fourth quadrant has positive x values and negative y values. Therefore, we are supposed to write the numbers on this particular axis. We start with the x-axis. The numbers are as follows. So our first number is 0. That is the point where the y-axis and the x-axis intersect. And that point is also called the origin. The second number is 1, followed by 2, 3, and 4. That means we have chosen interval 1 for the x-axis. We do the same for the y-axis and use the same interval 1 as follows. So for the y-axis, our values are ranging from 0 to 8. We can also be able to indicate the negative values for y and the negative values of x. So the first negative value for y is -1, and the first negative value for x in our case is -1. We now move ahead and plot the first point, that is 1, 3. This means the interpretation of that 1, 3 means the x coordinate is 1 and the corresponding y coordinate is 3. So we confirm where there is 1 and where there is 3. The point where they meet is where you put a dot or a cross as an indication of graphing. In our case here, I've used a large dot, which is visible. Then the second point is 2, 2. That means the x coordinate is 2 and the corresponding y coordinate is also 2. Identify on the x-axis where there is 2 and identify on the y-axis where there is 2. The point where they now intersect is our required point of plot. This is the point 2, 2. Finally, we plot the point 3, 1, 2/3. When x is 3, the corresponding y coordinate is 2, is one whole number, 2/3. So we have plotted that point. Having plotted the 3 points, you now join the 3 points. We discover that when the 3 points have been joined, they are giving a curve, and therefore that means that is not a straight line. We shall be able to now write on table 1 that whatever we are getting is nonlinear relation. Now we proceed with our second table and do the plotting. We have our grid here, which has still the x-axis and the y-axis. We start by plotting our first point, 1, 0. That means the x-coordinate is 1 and the y-coordinate is 0. So the first point has been plotted as 1, 0, as indicated with a big dot. We proceed and plot the second point, which is 2, 3. That means the x-coordinate is 2 while the y-coordinate is 3. You can confirm that the point has been plotted correctly. That is, x is 2 and the corresponding y value is 3. Finally, we plot our last point, which is 3, 8. That is, the x-coordinate is 3 and the y-coordinate is 8. You can verify that the point has also been plotted correctly. X is 3 and the corresponding y value is 8. You finally join the points . When the points are joined, we notice that we are getting a curve, and therefore the relation y2 is equal to x squared minus 1 is again nonlinear. We have confirmed that the second equation, y2 is equal to x squared minus 1 is non-linear, and therefore we are only remaining with the last relation which we want to confirm, whether it's linear or non-linear. Now, in our table 3, the coordinates are 1, 1. The second one is 2, 2, and the last one is 3, 5. So we start by plotting the first point, 1, -1. So the first point has been plotted. That is, the x coordinate is 1 and the corresponding y coordinate is -1. We move on to the second point, which is 2, 2. That is, x coordinate is 2 and the corresponding y coordinate is 2, and the point has been plotted using a big dot. Finally, we now plot the last point, which is 3, 5. So the last point has been plotted correctly. 3, x value is 3 and the y value is 5. Having plotted all the 3 points as per the table values, you now take out a ruler and join the 3 points. You will notice that once the points have been joined, all the 3 points lie on a straight line. And that means the last relation, which is our rule, y3 is equal to 3x minus 4 is a linear relation. Now, we can say that out of the 3 rules we have, only one is giving us a linear relation, and that is the last rule. Because we have obtained a straight line, it gives us a straight line. Now, we are going to extend the knowledge of linear relation to now plotting a graph of only straight lines in this case. We shall not consider cases where the graphs are not straight. We shall only deal with situations where graphs gives you a straight line. So in our first illustration, we are going to use the range given using a range of -3 to 3 to construct a table values and plot a graph for these linear relations. In our first case, we shall consider the relation y is equal to x plus 2 is an example of a linear relation. Then in part B, we shall consider a graph of y is equal to -2x plus 2. Let us start with the first one, part A, whose function is y is equal to x plus 2. Now, in our first function, y is equal to x plus 2, it is linear. Let us draw the table. Now, when the x value is 1, we can be able to get the corresponding y value by substituting in the equation. When we substitute the value of x as 1, we find that the y value is 1 plus 2, which is equivalent to 3. Next, we substitute the value of x as 2 in our equation and get the corresponding value of y. We find that when the x value is 2, the y value is 2 plus 2, which gives us 4. Finally, we substitute the value of x as 3. We find that when the value of x is 3, the y value will be 3 plus 2, which gives us 5. And that is the completion of the table. So that means we can be able to identify our coordinates from the table. And the first coordinate is 1, 3. The second coordinate is 2, 4. And the last coordinate is 3, 5. Having identified the coordinates, we can be able to plot and get the graph on the grid provided as follows. From the grid, we have plotted the coordinates very correctly. The first one is 1, 3. So that means when x is 1, the y value is 3. You confirm on the x-axis, where there is 1. Confirm on the y-axis where there is 3. Then make the plot. Confirm on the x-axis where there is 2, and confirm on the y-axis where there is 4. The point where they meet, you make a plot. And in our case here, we are using a big dot. However, you can as well plot using a cross. Having plotted all the 3 points correctly, you now take a ruler and join all the 3 points to get your graph. It has been drawn, and we can confirm that our graph is a straight line which runs to infinity to the right and infinity to the left. So these two arrows shows that the graph runs infinity to your right and infinity to the left. Infinity to downwards, infinity upwards. So we need to show that. However, you can as well define your graph by incorporating the equation of that particular relation. In this case, the equation is y is equal to x plus 2. That is how we plot graphs on linear relations. We now move on to reading of the X-intercept and Y-intercept. So, in our case, we are going to use part B to understand how to read X-intercept and Y-intercept. Now, we are considering a part B of our question, which will assist us to understand the meaning of X-intercept and Y-intercept. In this case, we shall still draw a table of values ranging from -3 to +3 by substituting each value of x in the linear relation as follows. When x value is -3, the y value is -2 minus 3 plus 2. And that gives us 6 plus 2, which is equivalent to 8. And therefore, we fill in our table, where there is x is -3, we fill the y value with 8. Then, when x is -2, find out the y value by substituting correctly. When x is -2, the y value is 6. Similarly, find the y value when the x value is -1. When x value is -1, the y value is 4. Do the same when x value is 0. So where there is x, we put there a 0. That leaves us with the y value being 2. We proceed when the x value is 1 and get the corresponding y value. When x value is 1, the y value will be -1 minus 2 times 1 plus 2 minus 2 times 1 is minus 3, plus 2, the result is 0. So that means when the x value is 1, the y value is 0. What happens when x value is 2? When x value is 2, then the y value becomes minus 2 times 2 plus 2. Minus 2 times 2 is negative 4. Plus 2, the result is negative 2. Finally, we substitute the value of x as 3 and find the corresponding y value. We notice that when the x value is 3, the y value is negative 2. We notice that when the x value is 3, the y value is negative 2 times 3, which gives you negative 6, plus 2, which gives us negative 4. We have completed the table correctly, and therefore we move to the second step of plotting the points on our graph. We shall ignore the first graph we have drawn using red and consider the graph that we are going to draw now using a black pen. So when x value is negative 3, y is 8. When x value is negative 3, the y value is 8 as indicated. Negative 3 is x, y value is 8 is indicated with a cross. As I mentioned earlier, we can plot using a dot or a cross, so that there is distinction between the first graph and this, the one that we are drawing. We have decided to use a cross in this case. The second point, the x value is negative 2, while the y value is 6. In the third point, the x value is negative 1 and the y value is 4. In the next coordinate, the x value is 0 and the y value is 2. When the x value is 1, y value is 0. When x value is 2, y value is negative 2. Finally, when x value is 3, y value is negative 4. Having plotted all the points correctly, we proceed and draw the straight line using a ruler. we notice that our graph is a straight line, and therefore we indicate the equation of our graph as y is equal to negative 2x plus 2. That is how we draw the table values, and that is how we plot the graph. The next equation is identify the x. Now we need to correct our equation because it is supposed to be y is equal to negative 2x plus 2. Now, we have drawn our table values correctly. We have used our table values to plot our graph. Therefore, the next equation is, how do I identify x-intercept and y-intercept from our graph? So we need to know the definition of the term x-intercept and y-intercept. X-intercept is a point where the graph cuts the x-axis. So the point where the y cuts the x-axis is called the x-intercept. That means is a point where y-coordinate is 0. In our graph, the point where our graph y is equal to negative 2x plus 2 is cutting the x-axis is at 1. And therefore, x is equal to 1 qualify to be called x-intercept. Next, for the y-intercept is defined as a point where the graph cuts the y-axis. That means the x-coordinate there is 0. So we read the point where our graph is cutting the y-axis. In our case, our graph is cutting the y-axis at 2. That means y is equal to 2 is called our y-intercept. That is how we identify intercepts. Now, we want to finalize by looking at how we can arrange linear relations in the forms shown here. The first form is y is equal to mx plus c. And the second form is ax plus bx, ax plus by is equal to d, where a, b, and d are just constants. In the first equation, in the first form, y is equal to mx plus c means x is a constant and c is also a constant. We shall start with the first equation, part A, and express in the form y is equal to mx plus c. To express the first equation, part A, in the form y is equal to mx plus c, we write as follows. You subtract 4x from both sides so that you only leave a value having y on the right-hand side. In this case, 4x minus 4x That means 4x is eliminated on the left-hand side. And the same applies on the right-hand side. Because we subtracted 4x on the left-hand side, you repeat the same on the right-hand side so that we don't change the sense of the original equation. So we now remain with the 2y is equal to negative 4x. And therefore, what will be the value of y? The value of y will be obtained by dividing each term by 2. So in this case, the value of y is equivalent to negative 2x. And therefore we say we have expressed the equation in the form y is equal to mx plus c. In our last part, we are going to express the equation y is equal to 4x minus 7 in the form ax plus by is equal to d, where a, b, and d are constants, while x and y are variables. So in this case, we subtract 4x from both sides. So it will be y minus 4x is equal to negative 7. Why? Because in our format, or the form we want to express our equation, the first term has x, the second term has y, and on the right-hand side of the equal sign, we have a constant. So we need to confirm that and ensure that the variables x and y terms are on the left-hand side, while the constant remains on the right-hand side. If we rearrange further, we can start with the x term, or a term having x, which is negative 4x. A term having y has a positive sign, which is implied. That's why it's not being shown. So the positive sign is implied. And therefore, the final equation is negative 4x plus y is equal to negative 7 after rearranging. And therefore, we say we have expressed in the form ax plus by is equal to d. And that is the end of our topic. You'll do some exercise. Now, class, you can now do question 1 and 2 as your exercise to practice the concept and the skill that we have learned on how to construct a table values and plotting a graph for question 1, and question 2 on how to arrange linear relations using the form y is equal to mx plus c, and also in the form ax plus by is equal to d. Thank you. Let us meet next time.